Okay, so far we have looked at simplifying expressions. We've also looked at evaluating expressions. The third concept that is fundamental to algebra that we want to talk about is solving equations. In section B.3, we are going to be looking at the two basic properties that we will be wanting to use in order to solve equations. The first one is the addition property of equality. In order to be able to complete this section, you want to be able to understand order of operations with integers. You want to understand the concept of an additive inverse. And you want to understand how to simplify algebraic expressions by combining like terms. Upon completing this presentation, you will be able to identify the difference between an expression and an equation, understand and provide examples of linear equations in one variable, and nonlinear equations. You will understand the meaning of equivalent equations, and you will understand how to solve basic linear equations using addition. So let's look at some vocabulary. The first thing that we want to talk about is an equation. This is a statement that two algebraic expressions are equal. The key word here is equal. Remember that an expression was just a combination of variables, constants, and operations. There was no equal sign. When we talk about equations, though, we are talking about an equal sign being in the original problem. That is the fundamental difference between an equation and an expression. Our second term that we want to look at is solution to an equation. This is a number that when plugged in to the variables, like we did when we talked about evaluating expressions, yields a true statement. What is a true statement in mathematics? It means that both sides of the equation are the same. 5 equals 5. It's not going to equal anything else. Next, what we're going to start with as we start our topic of solving equations, the first ones we're going to look at is linear equations. A linear equation is an equation such that each term is a constant or contains only one variable with an exponent of 1. Or, in other words, you will not see any variables. Some examples of linear equations. We have 3x plus y equals 7. Notice that every term here has at most one variable, no exponents. We also have 5a plus 7a equals 25. Same thing here. Note that the variable does not need to be the same in a linear equation. You can have multiple variables in a linear equation as long as you don't have multiple variables in a single term. Finally, we have linear equation in one variable. Linear equation in one variable is an equation that can be written in the form ax plus b equals c, where a, b, and c are constants. Now, notice it says that it can be written. Doesn't necessarily mean that it starts out that way. The main thing here is that in the previous example, remember that I said that you can have multiple variables running around. When we talk about in one variable, you can only have one variable or one particular letter that appears throughout the equation. So for instance, 5a plus 7a, this is technically a linear equation in one variable because a is the only letter that appears throughout the problem. We also have 3x plus 7 equals 9. This has only an x throughout the problem. Negative 15x equals 45 is another example of a linear equation in one variable. x equals 6.8. This is also a linear equation in one variable. So as you can see, linear equations in one variable, they can take many forms. But ultimately, as long as you just have one variable throughout the problem, then you're fine. It is a linear equation in one variable. Nonlinear equations. Well, technically our definition is this is an equation that is not linear. The reason that we refer to these as linear equations and nonlinear equations is we're going to talk about graphing in the next chapter. If you graph a linear equation, it graphs a line. Nonlinear equations don't graph lines. So when we look at them, let's talk about what does it mean to be nonlinear. This means that you can have terms that contain variables with exponents of 2 or more. You can have variables in the denominator. You can have more than one variable per term. You can have variables inside absolute value bars, and this list goes on. So for instance, if we look at the examples, 3x squared plus 7 plus 9, this is nonlinear because it's an x squared term. Negative 15 over x is nonlinear because the x is in the denominator. Absolute value of x equals 6.8. This is nonlinear because it's an absolute value equation. So those are some examples. Finally, our last term that we have is equivalent equations. Remember that we talked about the word equivalent before when we talked about fractions. Equivalent fractions were fractions that represented the same quantity. Equivalent equations are basically the same idea. Equivalent equations are equations that have the same solution. All right, so that's enough with vocabulary, so let's go ahead and see what else. The first thing that we want to start with is determining if a number is a solution to an equation. In order to do this, we're going to do just one more step from what we did when we talked about evaluating expressions. The first thing that we want to do is replace the variable or variables with the given values. We want to simplify each side of the equation by evaluating each expression. That takes care of what we did when we talked about evaluating expressions. So how is this different? The only thing that is different between determining if it is a solution versus evaluating an expression is the last step. If we get a true statement, then it is a solution. If it is a false statement, then it is not a solution. We're going to do a couple of examples of this, but note that in the long run, we're not going to have to worry about this. This is going to be our check step. And so when we get into actually solving equations, we're going to check our solution. If it is a solution, then we're good. If it's not a solution, then we might want to go back and try again. All right, so if we look at some examples, let's look at example A. Example A, we have 6x plus 16 is equal to 46. I want to know, is 5 a solution to the equation? Basically what we're asking is, when we talk about equations, we're kind of thinking backwards from evaluating expressions. I want to know if I plug in 5, is the result 46? So let's go ahead and see what happens when we plug this in. If we plug in 5, we get 6 times 5 plus 16, and I want to know, is this equal to 46? Let's simplify each side, mostly the left, If we follow order of operations, we get 6 times 5 is 30. If we add 16 onto that, we get 46 on the left side. We have 46 on the right side. That is a true statement. So in this section, what we will want to do is say 5 is a solution. That's the only difference between evaluating expressions and determining if it's a solution, is this final step of stating that yes, it is the solution. Let's go over to example B now. We're going to do the same thing. I want to know, is 7 a solution? So I want to replace every variable in my equation with 7. If we plug in 7, we get 2 times 7 plus 1 equals 5 times 7 minus 2. We want to simplify each side, so for both sides I'm going to start by simplifying inside the parentheses. On the left side we get 7 plus 1 is 8. On the right side we get 7 minus 2 is 5. We can now go ahead and multiply. 2 times 8 is 16. 5 times 5 is 25. And this is not a true statement. 16 is not equal to 25. So all we can say is 7 is not a solution. You do want to be very careful when it's not a solution. Note that, or if you think about the statement, if I say 7 is not a solution, is that the same thing as saying no solution? They are completely different statements. When you say not a solution, you are talking about a specific number. Whereas if you say no solution, that means there is not a single number out there that will make it a true statement. So be very careful that when you are looking at individual numbers, you use the phrase not a solution instead of no solution. So now let's talk about the addition property of equality. We don't necessarily want to go around checking every single number out there to determine if it is a solution. So we want to talk about how are we going to solve equations. The first property that we have is the addition property of equality. What it says is if A is equal to B, then I can add the same number to both sides and I will still have a true statement, or I can subtract the same number from both sides and it will still be equal. Now it looks like we're making it more complicated, but we're actually going to use this property in order to simplify our equation. So our procedure in order to do this, we want to simplify each side of the equation by combining like terms. From there, we want to isolate the variable by adding or subtracting terms from both sides. This is going to be similar to what we did when we worked with fractions. Remember that in fractions we had the rule of whatever you do to the top, you do to the bottom. Working with equations is very similar, but even more flexible. With fractions, this only worked with multiplication and division, whereas with equations, you can add, subtract, multiply, divide, and the list goes on. The main thing to remember with equations is whatever you do to one side, you have to do the same thing to the other. Alright, so let's go ahead and look at some examples so that we can see how this addition property works. So the first example, you can probably look at this and know what the answer is. What minus 3 is equal to 11? Well, if you think about it, we should have the answer of 14. So now here's the question. How do we get from x minus 3 to just an x? And how do we get from 11 to 14? On the left side, we need to get rid of subtracting by 3. On the right side, we need to get from 11 to 14. So what we want to do, in order to get rid of minus 3, I want to add 3. To get from 11 to 14, same thing, I want to add 3. So if we add 3 to both sides, what happens? My minus 3 and my plus 3 cancel, leaving me with just x. And my 11 plus 3 gives me 14. And so that's how we want to approach each one of these problems, is when we talk about isolating the variable, we want to move constants to the other side or move terms to the other side by adding the opposite. So let's look at some more examples and see what we can do here. Let's look at example B. Example B, we have z plus 1.4 equals 2.06. Now don't let the decimals confuse you. Think about what we need to do. How do we get rid of a plus 1.4 on the left? Well, to get rid of plus 1.4, I want to subtract 1.4. And remember our rule, whatever we do to one side, we have to do to the other. So if we subtract 1.4 from both sides, on the left side it cancels, leaving me with just a z. And on the right side, if we subtract 2.06 minus 1.4, we should get 0.66. And you're done. Okay, so let's kind of step up the difficulty level just a little bit. Let's look at example C. Example C, we have a lot of stuff going on here. But remember that our first step before we start talking about solving is we want to simplify the expressions. We want to simplify each side of the equation. Now the important thing to remember is each side of the equation is an expression, meaning that all we're going to do is combine like terms. So the first thing that I want to do is combine 5y and negative 4y. What is 5y and negative 4y? Well, we have different signs. We're going to subtract, keep the sign of the larger, and we get y. The next thing we want to do is combine the constants. We have a plus 3 and a minus 8. Again, same signs. So we're going to subtract, keep the sign of the larger number, which was the negative 8. So we're going to get y minus 5. That's the left side. On the right side, we want to add 6 and 9, and we get 15. Now, this particular step is just about simplifying expressions. It has nothing to do with solving equations. We're not using our solving equation steps. Once we have simplified each side, now we can go ahead and use our solving steps. So in order to get y by itself, what do I need to do? I need to get rid of the minus 5. What is the opposite of negative 5 or subtracting 5? The opposite of subtracting 5 is adding 5. So I want to add 5 on the left side, and I want to do the same thing to the right side. So we get y equals 20. And we're done. Now, one of the important things to remember is that when you change signs, you can only do that when you are moving to the other side of the equation. For instance, when you simplify, if you want to rearrange your terms and get your like terms together when you are simplifying each side, that's fine. Just remember that you have to keep the same sign with the term. Meaning, I don't want to change that minus 4y to a plus 4y to combine it with the 5y. That doesn't work. Okay, because we did not do the same thing to both sides of the equation. So be very careful when you're doing this. Let's look at a couple more examples and see what we can do. If we look at example D, we have 4x equals 7 plus 3x. Now, not only can we move constants to the other side, we can also move variable terms to the other side. Now, this is where I start using some analogies. To me, equations are very cliquish. Variables want to be together, constants want to be together. They do not want to be with each other, though. So, for instance, if you want, this is kind of the Red Rover step. You want all your variables on one side of the equation. You want all your constants on the other side. And so, for instance, on this one, before we can solve for x, we need to get all of our x's together. We need to get all of our ducks in a row. So, just like we did with the constants, the first thing that I want to do is I want to get the 3x away from the 7. In order to do that, I want to subtract 3x from both sides. On the right side, it cancels out. On the left side, I get 4x minus 3x is 1x, or just x. So we get x equals 7. And that's it. All right, let's look at one more example. Example E, we have 3y minus 9 equals 2y plus 6. Now, me personally, when I start working with equations, I prefer to move my variables first. I'm going to do this in 2 steps. So the first thing I want to do is I want to move 2y to the other side. Since it is positive right now, I'm going to subtract it. We get y minus 9 equals, my 2 y's cancel on the right, leaving me with just a 6. The next thing I want to do is I want to get y by itself. I want to get all of my constants together. So I want to get rid of the minus 9. In order to do that, I want to add 9 to both sides. What's the opposite of subtracting 9? It's adding 9. So we get y equals 15. And we're done. Now, one of the nice things about equations is you don't have to have someone check your work for you. Remember, in the previous slide, we talked about determining if a number is a solution. Basically, what it means is you can check your own work. And all we're going to do is plug the number in and make sure that both sides of the equation are the same. So let's look at example E and check our solution for this. If we check our solution, we get 3 times 15 minus 9 is equal to 2 times 15 plus 6. Okay, so the first thing I want to do is multiply. 3 times 15 is 45 minus 9. 2 times 15 is 30 plus 6. 45 minus 9 is 36. 30 plus 6 is 36. and this checks out. Now, all this tells me is that yes, y equals 15 is the solution. So that takes care of solving equations using the addition property of equality. So, now that you have finished the presentation, if you feel comfortable with it, go ahead and try the following problems on your own. Bring your solutions to class as well as any questions that you may have.